Okay, so in this video, we are going to learn how to divide um, facade into panels and then how to make perforations on them. So something like this will be the result. And we will use Grasshopper for that. So we will start by inputting this surface into Grasshopper. So right click, set one surface. And now we can just hide this one. And usually I like to work in Grasshopper with this one on. That means that I don't see anything unless I touch a component. Again, this one here. And the first thing that we will do is we will use a divide domain component. And we will add some sliders here to the U and V count. And to a shortcut for the slider is you put the first number that you want to use and then the second number. So 0 dot 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 30. That will give you a slider from 0 to 30. And let's just copy and paste this one here. Okay, and then we will use a isotrim component to divide the surface into segments, and you will see the results here. You can preview the results here. So as you can see here, we are controlling the number of spacing of the panels in both directions, which is very convenient. And this is already creating trims in that surface. And a simple thing that we can do is we can maybe extrude these panels based on the distance to this point, let's say. So let's try doing that. I will first input that point here in Grasshopper. Right click, set one point. So I have a point, I have a surface, and then I can use the extrude component. So this is what I would extrude, and the direction, sorry, the amount of extrusion will be based on the distance to this point. So we can first get the center of the surface, and we will do that using an area component. So basically this will give us the center of the area, and we can get the distance between this point and this point, and that can determine the extrusion quantity. We also will need the extrusion direction, because as you can see, this one is a tilted panel, so I want really to have these extruded in this direction. So then I can do that by using the surface closest point component and evaluate surface component. And then I will grab this surface, and then I will grab this center point to evaluate. So again, this one comes here. Okay, and now as you can see here, you kind of have planes that indicate the direction of this one. Okay, so now that I have that, I can use the normal here, which is pointing this way. Maybe I can display that. Yeah, so there you can see this direction we will use for the direction of extrusion. So anyways, I'll just get rid of this one, and I will use a vector magnitude. I think it is the name. Oh, amplitude. So now I have my vector, and I will use this as amplitude, and let's see what that gives us. Okay, so there, as you can see, the panels are being extruded based on the distance to this point. So if I move this point, wait, where's my point? Here. Yeah, if I move that point, these all get moved, right? But this is probably too much. So then we can just divide these numbers, because these numbers are two. I'm just going to put a panel here. Shortcut is 2/ like this. And then if I connect the output, I will see that these numbers are too big. So then to make these numbers smaller, I can just divide these numbers into, let's just make a slider here. So then we can see how that changes. Okay, so something like that, probably. It's more subtle. And here, okay, so this is the first thing that we can do, like define the extrusion of these panels. And as you can see here, everything is nicely extruded based on the location of this point. Okay, another thing that we can do is we can, let's just bake this to have as a example of what we did here. Maybe before baking, I'll just, no, I'll just bake this. Mhm. To have as an example of what we did. Okay, so that's number one. Another thing that we can do is we can just select some of these patterns randomly. So we can use a Cull pattern component. And here we can use a panel to control what kind of, as you can see here, if you hover here, the default is false, false, true, true. So what we can see is false, false, true, true, false, false, true, true, false, false. So that's how it's selecting it. If you want to have control over the selection, we put a panel, we right click on the panel and say multi-line data. And then we can say, for instance, true, false. And this will basically give us a like true, false pattern, as you can see here. But this is not that interesting. So let's do true, false, false. Oh, sorry. True, 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 false. And if we divide this into, oh, we change this one, it becomes more interesting. Hmm? Like this. Okay. And then, of course, we can just choose to extrude these ones instead of all of them. So everywhere where we had this one connected, we can replace them for this one. And you can see also these are being extruded based on the distance to the point. Let me see here. Let me change the numbers boundary here. Okay, so something like that. I'm just gonna put this one closer also, so you can see the difference. Okay, so right click and bake also. And I will copy this to the side. Another example. Okay. Something else that we can do is we can create perforations in these panels. And let's do that. So we will, from these panels, we will get the wireframes. So basically the lines that conform the panels. But if we see the output here, we see that these are all separate curves. So each one of these curves is in a separate line. So we want to avoid that. So we want to get the full closed lines. So I'm just gonna use a joins curves component. So then you will see it's a closed line now. And I will use a curve offset because I want to create perforations inside a frame. I'm gonna use this one. This one. Okay, and then I will use negative value for the distance here. And I'll use a slider here to define that value. Okay, so this is the original curve, and this is my little frame here. I'm also just going to decrease these values just a bit. Okay, there we go. So now I will make perforations inside this one here. And I will do that by using a surface frame component. And I will just get the points from these frames. And I will decrease this count because maybe it's okay, but I will put sliders here to control the amount of points. Okay, I'll just leave that like that for now. Maybe this one I will make more. There we go. Okay, so now we have the points, and I will use those points to make little circles for perforations. Of course, the radius is too big, so let me just change that. Okay, maybe that's okay. Okay, from these circles, I want to make holes on my original panels here. Here. So I will use a surface split component. I will also use here a data dam because I don't want to, this one is a very heavy component, so I don't want it to run every time I change something here. I will just let it run when I press play here. But this is optional, of course. So this one is the one that I want to cut with these ones, right? Surface and curves. But first, I need to check the data structure of this and compare it to the data structure of this. So let me do that to see what we need to do to match them. Okay, so here we see that every 8 circles, so like 1, 2, 3, 4, 5, 6, like yeah, every one of these lines, 3, 4, 5, 6, 7, 8, is on a single list. And that's bad because that will create unnecessary, like it doesn't match the data structure of these panels that are organized. Each one of them, each one of these should be organized in a single list. So let's do that first. So we'll graph this one. And now you will see that each one of them, and I'll just right click and do simplify just so that it's more evident. This is kind of the data structure that I want for this one, which is that every surface, it's in its own list, and I want all of the circles for a single panel to be in the same list. So I'm going to do that. I'm going to use a shift paths component, and that will give us so we have like 56 circles per each panel, which is per each panel, and these are organized in a single list. So I'm just going to simplify this so that you can see. And now the circles and the panels have the same data structure. So now I can use this component and make sure that the results will make sense. So now this one will go here, and this one will go here. And now I will just click here. It didn't take that much to compute, but now you see that I have many split results because it also has one split result per each one of these. So I'm just going to grab the panel, and so I'm going to use a list item here, And you see we have like 24 panels, which was our initial panel count. Okay, so now I can just bake this one. Of course, I can also make the radius of this little circles depend on their distance to this point. But I think I showed this in another video. Okay, then I bake this one also. Okay, so simple things that you can do with dividing surfaces into panels and also making perforations or extruding them based on a distance. Okay, and of course now this is parametric, so you can adjust all sorts of things, the size of the and all that. Hmm? So again, here this one doesn't run until I press this, and there you can see the result. It's probably too big, but you get the point. You can also change the number of panels here and so on. And this is good to explore kind of how to divide a surface into panels by just using these two components. And that's it.